All right, so just real quick, back on the same point, I just drew these kind of things here. I'm gonna, when I export the slides, so this will be here, just showing that this, in this region here, this range of frequencies, the capacitor basically acts like an open, and that's why we get the output equal to the input for this range of frequencies. Out here, the capacitor basically acts like a short, so for this range of frequencies all the way out to infinity, the capacitor acts like a short, and so that's why we get output voltage to be 0. And then in between here is kind of where all the interesting stuff happens. Okay, so just wanted to leave you with that so that that was clear what I was talking about in the previous video. And in this video, I want to talk about what's called the cutoff frequency. So it's a particular frequency for circuits like this. When we talk about frequency response, some frequency, which in this case is right around here, it is where the output is equal to 0.707 times the input. It's a very interesting number. You're probably thinking, why in the world is that a value of interest? Well, this number here is something you'll probably get used to and memorize, but it doesn't just come, it's not arbitrary. It actually comes from this expression here. So let me go grab it. Sorry, I have to go back some slides. It's our magnitude expression that we've been looking at all this time. But it is a particular frequency. Okay, so let me basically drop it in here. It's a particular frequency where the magnitude goes to a particular value. And what value is that? Well, let me rewrite this. Let me show you that there's a different way we could write this expression here. We could write it as 1 over 1 plus f divided by 1 over 2 pi RC. Hope you would agree with that. Squared. This 1 over 2 pi RC is called the cutoff frequency. Okay, that is called the cutoff frequency for an RC circuit in particular. There's also cutoff frequencies for RL circuits, other types of filters. I'm not talking about filters just yet, but this is an important frequency because what happens when F is equal to FC? So let me rewrite this magnitude function based on that discovery that we just made. Oops, I left the pi behind. So we can rewrite this as 1 over 1 plus F over FC squared, right? And so what happens if I evaluate this at F equals FC? So basically, FC is some value dependent upon the R and the C value of our circuit. What if I look at the frequency where F is equal to FC? What happens? If I let F be equal to FC, then this term goes to 1, correct? And so the entire magnitude becomes the square root of 1 over 1 plus 1, or the square root of 1 over 2, which is equal to 1 over the square root of 2, which is equal to, I hope maybe you've guessed it by now. Let me just throw it in my calculator. 1 over the square root of 2 is equal to 0.707, okay? And so what did I say here? Well, the cutoff frequency is where the output is 0.707 times the input. And so if I were to look at Vout over Vin, of course, that would be 0.707, which of course, again, still, I'm only plotting the output because I know that my input is 1 volt, but you should always plot the input, the ratio here. But right here, I'm basically saying for an input of 1, I'm getting an output of 0.707 times 1, or 707 millivolts, right? And that is at the cutoff frequency, which in this case happens to be 159 hertz. And so let's just, for a sanity check, let's make sure that that's the case. Let's see, FC is equal to 1 over 2 pi times 1K times 10 to the minus 6, right? This is my kilo ohm resistor. This is my 1 microfarad capacitor. Let me pass that into my calculator. 1 over 2 pi times 10 to the 3 times 10 to the minus 6, and I get 159 hertz. Okay, so that is the cutoff frequency of my circuit here, my RC circuit. and that is at a frequency of 159 hertz. And that is the frequency where the output, basically the ratio of the output to the input, is 0.707, okay? And where does that come from? It comes from the fact that I am saying that my frequency that I'm looking at is my cutoff frequency, right? I'm saying F is equal to FC. That results in this entire thing going to the square root of 1 over 2, or 1 over the square root of 2, which gives me 0.707. Okay, so that's an important thing to note. A lot of times it'll say, what is the cutoff frequency of this circuit? What is the cutoff frequency of this filter? Now you know what the cutoff frequency is. It's basically the point where the frequency that we're operating at is equal to the cutoff frequency of the circuit. Or it's the frequency where this entire term of the magnitude goes to 1, so that we get 1 over the square root of 2 for our magnitude of the transfer function, okay? So I'm going to go ahead and end this video here, and in the next video I'll finally get into the next example, which is basically doing all this over again, but for the RL circuit.